Hi guys! Today we're going to find the diagonal length of 3D shapes using Pythagorean theorem. There's two steps. We're basically going to use the Pythagorean theorem to find the hypotenuse of two different triangles. So let's get started. We have our first example here, and if you haven't reviewed shapes and understanding what side lengths are parallel or equal, definitely review that. But today, what we're going to do is we're going to find two different triangles within our 3D shape. So this will be our first triangle. Find the side length for this magenta line, and then we'll use that to find the side length for this gold line, the diagonal. So let's get started. We know that since this bottom piece here is a rectangle, this side length must be the same as that side length. So since this is 7 centimeters, we can assume this is also 7 centimeters. We'll take this side as 12 centimeters, so we could do A, B, and we're going to try to find C, our hypotenuse. We're going to use our Pythagorean theorem, A squared plus B squared equals C squared. Plug in A and B, so 7 and 12. And then we'll go from there. 7 squared is 49 plus 144, which is 12 squared. Add them together, we get 193. So our final step is we need to find the square root of 193 because right now we have our question mark squared. So to get it just to be the question mark, we're going to have to find the square root of both. And in rounding, I ended up with a result of 13.9 for my question mark length. So what we're going to do is we're going to take that answer and now apply it to this second triangle. Our end goal is we're trying to figure out what D is. So we figured out this length to help us find that length. So now we're going to go through the steps again, and this time we're going to look for D. We're going to try to find the diagonal length. So I noticed over here that this is 6 centimeters, and we know from squares or rectangles that these opposite side lengths would be equal, so this would also be 6 centimeters. So we're going to take our measurements and plug them into the Pythagorean theorem. So we took our new side length we just found, 13.9, plus this side length, which is 6 centimeters. We're going to square those. 193, I rounded, plus 36 equals D squared. Get the square root of our total, which 193 plus 36 is 229. And we'll get an answer of about 15 if I round. So we found our diagonal length is 15. So notice we just went through our steps twice just to find D. And you guys can do this. You guys can do the Pythagorean theorem. Let's try another example. So once again, step 1, we're going to try and find this side length in order to find that diagonal. So we're going to use the units they provided for us. We have 18 and 11. I plugged them into A and B in my formula, and we're going to try and find C. This is the hypotenuse. 11 squared, 121. 18 squared, 324. Total of 445. We square root both because we want to get C by itself. If it's C squared, we have to do the square root, the inverse operation, and we'll get an answer of about 21. So 21 would represent our C length, but our end goal is we need to find our D length. So we're going to have to do that again. So once we plug in 21 there, now we can do 21 and 14 as our side legs, and we'll try to find D. So 14 squared, 196, 21 squared, 441. Add them together, you get 637, and then we're just going to find the inverse operation, the square root, with an answer of 25.2 for our D, for our diagonal length. So once again, I rounded to the 10th, I rounded to the whole number. Just follow the directions, whatever it says on your assignment. So go ahead, guys, and practice this. I'll be here if you need me.